Okay, so chemistry welcome to 4.6. What should have happened already is you taking a 4.6 quiz and now you're ready to grade it. If you didn't yet take a 4.6 quiz, pause the video and take your 4.6 quiz. So assuming you've taken the 4.6 quiz, here are your answers. 1 is attract, 2 is energy levels, and then we're back into our old time questions. 3 is atomic mass unit, or AMUs. 4 is carbon 12. 5 would be 12 AMUs. 6 is Dalton. 7 we have protons, neutrons, electrons. Protons would be a P with a little plus in the exponent position. Neutrons an N with a 0. Electrons E with a minus. For masses, protons are 1 AMU, neutrons are 1 AMU, electrons are negligible mass. For charges, protons are a positive 1, neutrons are a 0 or a neutral, electrons are negative 1. Then there's drawing a picture. So, drawing a picture, we have ourselves a nucleus. The protons go inside, the neutrons go inside, and then the electrons go floating about. Mass number is a new-ish question. Mass number, the idea is you're adding up the number of protons plus the number of neutrons. So somehow you have to have like an adding type word in this answer. If you just say it's the number of protons and neutrons, you make it sound like if there's 8 protons and 8 neutrons that the mass number is 8, because that's the number of protons and neutrons was 8. The mass number there would be 16 because it's adding the protons and neutrons together. So we need an adding word for the mass number question. The atomic number is just a count of the protons. So the number of protons is that one. An ion is if you gain or lose electrons. Electrons may come, electrons may go. That makes that an ion. If you just said gain electrons, we'd go half. If you said just lose electrons, we'd go half. That type of a thing going on there. Energy levels is a series of areas outside the nucleus where the electrons go. So if you didn't have a word like series to say there's lots of levels, that would be a half point sort of a word. If you weren't talking about the electrons being there, I think you're out of luck on that. If you didn't say it was outside the nucleus, I think you're just out of luck on that. So if you said area outside the nucleus where the electrons are, I'd go half. But here, my little dotted thing, I drew you a 1 energy level. Isotopes have, you could explain this in a variety of ways. You could either say it's the same atomic number and different mass numbers. It's probably the best way to explain that. What causes isotopes are if you have different numbers of neutrons from atom to atom. 28, chemical properties are the same, physical properties are different. For example, carbon 12 and carbon 14 are isotopes. They have the same chemical properties, like you could have chemical properties. So like if that could be burned, you could burn both of them. The physical properties are different. Like if you have something that boils at 80 and you do an isotope, it might not boil at 80 anymore. Okay, so the physical properties can be different. The chemical properties have to be the same. If one of them rusts, they both rust. If one of them freezes at 0, maybe the other one doesn't freeze at 0. Physical is different, chemical is the same. And then the last question is that these are an average. Since averaging in math involves dividing, if you're doing an average, you don't usually get a whole number because often things don't divide evenly. So that last one it's an average. If you have a question about scoring, just write a question mark next to it now while it's fresh on your mind that you had a question, and then we'll worry about sorting that out once we're seeing each other face to face. Quick question or quick commentary back on the picture drawing moment. That question, I think the picture was worth 4 points. So like labeling the nucleus would be a point, protons are a point, neutrons are a point, electrons are a point. You only get the points if you draw things in the right location. But generally speaking, that's a 16-point zone. So that picture is multiple points. As we step into next time, the read for next time will be 4.7. So 4.7 is going to have 6 new points. Then everything from today's number 3 and down just stays the same. Yep, that's all the same. The order's a little different, but the questions are the same. So just be on the lookout if the order of something changes. Today, up to the top, number 1 doesn't reappear, that opposites attract. Maybe that's back for the test. I'm not sure. Number 2 becomes a 2-point question. It'll be fill in the blank. The blanks you'll fill in will be Niels Bohr and increase. So we're going to need to know Niels Bohr's name, and then you'll have sentence, 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 including the energy levels will be part of a sentence. And then you'll fill in the blank with increase, that as we go through the energy levels, they increase in energy. I'll have a follow-up question, how many levels are there? And there are 7 levels. I will have a question when you go to a lower, this will vary day to day. If you go to a lower level, you have to blank energy, or if you go to a higher level, you have to blank energy. That'll be a fill in the blank. Since the closer levels have more energy, if you go up a level to a higher level, you would have to absorb energy to do that. If you're going to a lower level where there's less energy, you'd have to emit energy. So tomorrow, if I say you're going down a level to a lower level, what do? You emit energy. If I'm taking you up a level, higher level, you'd have to absorb energy. Another question off of today's from the reading that's new, for an electron to be able to go down an energy level, what has to be true? There has to be a vacancy. In other words, an opening. Like, you might have been ever looking for a hotel room, you pull up, it says no vacancy. There's no room for you. Or you might pull up and say vacancy. That means there is a room for you. If an electron's ever going to try to go down an energy level, there has to be a vacancy at that level, meaning there's an opening at that level. So that's our quiz. Again, to summarize, 4, 7, 6 new points. Everything from 3 down stays the same other than tinkering with the order. New questions, 1 is gone. 2, you're filling in the blank with Bohr and increase. You need to know there's 7 levels. You need to be ready to either go down a level by emitting or up a level by absorbing. And you have to know that you can only go down a level if there's a vacancy. There is some homework on this, and so here's a little bit of homeworky information. Energy level 1 is the smallest energy level because it's the tightest to the nucleus. That's where there's the least energy, and it's also able to accommodate only 2 electrons because it's just not very big. Level 2, we can do a little more energy. It's a little bit of a bigger loop because we're a little bit farther from the nucleus. You can accommodate more electrons. Level 2 can accommodate as many as 8 electrons. Level 3 gets a little bigger still and can accommodate a little bit more. Level 3 can take 18. And then I'm tired of drawing energy levels and I'm running out of board space. So I'll just tell you, level 4 can hold 32. Level 5 can hold 50. Level 6 can hold 72. The next level can hold 98. I don't know if that makes the test. I don't know if you want to memorize a series of numbers, if you have to. But these are based off of a pattern. There's a formula here that you can do any level with the math 2n squared. So if you wanted like the 5th level, 5 squared is 25 times 2, that's 50. If you want the 7th level, 7 squared is 49 times 2 is 98. This equation can give you any of the levels that you want to get. For right now, the homework tonight is only going to worry about things on the first couple energy levels. I think the highest you're going to go, anything on, is level 3. What we'll learn about later in the chapter is you don't always have you can have vacancies at certain levels. So you aren't always gonna, as we fill these up, level 1 isn't always, level 5 isn't always full before electrons start to live on level 6. Okay? As electrons come and move into these orbitals, these levels, sometimes you have partially full levels. And that's a conversation for another day. That starts to happen in the upper levels. Tonight's homework is going to stick to the more basic levels, and they're going to ask you to draw some diagrams tonight. So here's a sample problem. If I talk to you about oxygen, and I stick a 16 here and an 8 there, ask yourself, do you know what the 8 is called? Maybe you do, maybe you don't. If I were here, I'd wait until somebody said it. This is the atomic number. If I were here, I'd ask you what the atomic number counts, and I'd wait until somebody came up with it. That counts protons. Okay. So what they're going to want you to do in the homework is draw yourself a nucleus. You don't have to call it nucleus if you don't want to. But in here, write that there's 8 protons that live inside. We're basically mimicking our picture we've been doing on the quizzes. If I were here, I'd ask you what that number is for, and I'd wait until somebody said mass number. I'd ask what that measures, and I'd wait until somebody said it. This is the protons plus the neutrons. Okay. If we already decided there's 8 protons, and we decided there's 16 total protons and neutrons, what that's telling you is that there's also 8 neutrons in the nucleus. It's a coincidence those numbers are the same. Usually those numbers are different, but they're usually not different like dramatically. You're not going to get 8 protons and 400 neutrons. It's usually pretty close, ballpark. Then we also want to figure out the electrons. The deal on electrons is that the proton count always matches the electron count on something without a charge. So what we have going on here is 8 electrons floating around the nucleus. They're going to ask you to draw these in levels. And I think instead of drawing a whole bunch of circles, it's going to be easier to just draw a blank. Instead of drawing a dotted circle circling that for level 1, just draw a blank to represent level 1. And level 1 can only hold 2 electrons. Then we have another level farther away. I'll draw another little blank to represent the second energy level rotating around this. Since we had 8 protons matching electrons, we need 8 electrons. We've accounted for the first 2. There's got to be 6 more electrons floating somewhere. Level 2 can accommodate up to 8 electrons. So all 6 of those electrons could live at level 2. This is the kind of thing they're looking for you to draw tonight. So one more just to make sure you got it. So I say 40, 18, argon. Okay, the lower number, the atomic number, counts the protons. So we draw ourselves a nucleus, and we're going to stick 18 protons in there. The upper number, the mass number, is the protons plus the neutrons. So you're going to have to subtract. If there's 40 total, 18 of which are protons, subtract to figure out the other 22 are neutrons. When we go to do the electrons match the protons. So I'm going to have to do some levels out here until we get the electrons adding up to 18. Okay, so first level can hold 2 electrons, because this says so. Level 2 can only hold up to 8 electrons. We're trying to total up to 18. So we're going to fill that level up. There's going to be all that level's full, 8 electrons there. Now we've got a total of 10. There's 10 electrons filling the first 2 levels. There have to be some electrons in the third level because we've got to get up to 18. So 2 and 8 is 10 so far. We need 8 more electrons at level 3, which works out fine. Level 3 could take as many as 18. We don't need 18 more. We need just 8 more. So we're going 8 there. What you can't do is think, oh, I got 18 electrons. Level 3 holds 18 electrons. Let me throw all my electrons into level 3. That's not how this works. Until level 1 is full, there's nothing happening at level 2. Until level 2 is full, there's nothing happening at level 3. It's either level 3 or level 4 where we start to fill one while we're filling others, and that's again a conversation for another day. Okay, but you've got to fill level 1 with 2 electrons. before any electrons go at level 2. And you have to fill level 2 with 8 more, having a total of 10, before you even think about level 3 getting any. Okay? But this is the kind of drawings you're going to try to draw tonight. You don't have to label the nucleus, but tell me how many neutrons are in there, tell me how many protons are in there, and then level by level start going. This will be 2 or less. If it's more than 2, we can go anywhere from 1 to 8 here. If we fill this one, we move up to here, and they're not going to do anything. I don't think in the homework going above level 3, because I don't think we know how to do that until we get some more knowledge later in this chapter. So, that's it. See you soon.